Hi everyone, this question has been taken from Olympiad Pathfinder. Multiple choice question number 30 from the chapter 2 related to Newton's law of motion. The question goes like, a massive bead is threaded on a long light rod. Light means massless rod. One end of which is pivoted to a fixed point O. This is O where it is pivoted, and this is the massive bead. Initially, the rod is held horizontally and the bead is at a distance L from the pivot. From here to here it was L. Coefficient of friction between the rod and the bead is mu. So which of the following statements correctly describe relation between the angle theta that the rod makes with the horizontal after the rod is released and the time elapsed is t, means in t time when it is released and in t times when it comes somewhere here, so that is making an angle theta. So it is asking, how is theta related to, so what is the value of the angle theta? So that basically we have to find out. Okay, and there are four options. A is mu is negligible, theta tending to tan inverse gt square by 2l. B is if mu is finite, theta tending to tan inverse gt square by 2l. If mu is finite, theta is smaller than tan inverse gt square by 2l by a finite amount. There is none of the above statement is correct. So let us discuss this question and reach to the solution. So this is the diagram I have made when the rod after t time rotate from here to here and take the position this, and this is the angle theta. So initially in the question it is given that L is the distance of the bead from O, okay, when it was here at t is equal to 0. It is released, it started falling, but since it is hinged at point O or pivoted at point O, so it will rotate, the rod will rotate about O. After t time it has come to this position, angle is theta. We have assumed that L plus x is the new position of bead while it came from here to here, while the rod took the position at angle theta from the horizontal. Okay, for solving it, we have assumed that m is the mass of m, capital M is the mass of the bead, and N is the reaction force acting on the rod due to the bead. The bead is applying a force N due to reaction on the rod. Okay, O is the hinge point. So this is the free body diagram of the rod. L plus x is the distance at which N is, because bead is here, so N will be here. So you can take either direction, but it is fine. So we have taken right now that it is acting in this direction, since the rod is rotating from here in this direction. Okay, let us consider the torque on the rod about the point O. So torque is force into perpendicular distance. So N into L plus X is equal to moment of inertia of the rod about point O, that is I, into angular acceleration. But the rod is massless. Rod does not have any mass. It is in the question given that it is light. Light means massless. M is 0 for this. So hence moment of inertia will be 0. So n into L plus x will be equal to 0. So let us say this equation as 1. But if you see this equation, L plus x is a distance. In this case, L plus x will never be 0, right? So to satisfy equation 1, so what should be 0? N should be 0. Therefore, we got a value of n that it will be 0. Okay. Now we will make the free body diagram of bead. Since bead is exerting a force N on the rod, so N as per the Newton's third law will exert a force on the bead equal and in opposite direction. So N is shown here in this direction, so N on bead will be in this direction. Other force on bead is mg. But from equation, but we have got that N is equal to 0 from here, from equation 1. And we know that the friction force is mu into N, right? But N is 0, so it means there will not be any friction force on the bead, right? So only force now acting on the bead is mg, that is the gravitational pull. So it is clearly evident, it is evident now that the bead is falling freely with acceleration g in the downward direction. Okay. So initial position of bead was at A and B is the position at time t, right? Since it is a case of free fall, so bead will be falling straight down, right? So therefore BA will perpendicular on OA. Okay. This we know OA is L. OB we have taken it as L plus X, right? In the previous page you can see that. So since it's a free fall case, so in t time, in the bead will fall with a height half into g into t square. So now from this triangle we can take tan theta. Tan theta is AB by OA, so gt square by 2l, right? So theta will be tan inverse g into t square by 2 into l. So you can see clearly that in this expression mu has never come, right? The coefficient of friction at no stage has come into our calculation because the reaction force between the bead and the rod N was 0. Okay, so therefore, irrespective of the value of mu, theta will be tan inverse gt square by 2 into L. If we go in the options, so you can see that option A and B are correct. So hopefully you understood these questions clearly. Question and solution clearly. In case any doubt, please write in the mailbox. I'll come back to it. Thank you.